Alright, so since all of you like my sex game, I mean my first game that I made for Ludum Dare 24, I did a code review on it, video up there. I thought, and correct me if I'm wrong, but I thought it would be a good idea to remake that game in C++, to take it from the original Java code and essentially port it to C++, optimize it, fix some bugs, show some different ways of doing things, and use it as like a teaching example to show you guys how I would even approach something like that, and to hopefully discuss like some good ways of essentially remaking this game. Because that way, instead of looking at like existing code that other people have written and then just speculating, oh, I would do this, I would do that, I'm actually forced to write the code. We're going to actually build this, obviously from scratch, because the original code is in Java. And along the way, hopefully in each episode of this series, we'll kind of focus on specific things so that you don't necessarily need to watch like every episode and the whole series unless you want to watch all of it. You can kind of pick and choose. Choose your own adventure. So for those of you who missed it, this was the original game. It's called Genesis. There's like a main menu. We're gonna remake all of this. Like the idea, like I'm gonna use all of these assets. We're gonna remake it completely. The goal is for you not to know if you're playing like the Java version or the C++ version. It needs to be the same. That's kind of the point, except I might fix some bugs because I think there's like a lighting bug. But anyway, when you hit play, this is what happens. It loads this kind of level from a file. We can move around. One really important thing to note is that like the way that this game actually works is these pixels are all kind of rendered individually into a kind of pixel array. So this is kind of like essentially what you would call software rendering or software rasterizing, because we're doing all of this on the CPU. So instead of kind of, you know, uploading these images as textures to our GPU and getting an API like OpenGL or Vulkan or DirectX to actually draw, you know, these triangles and shade the pixels with like the colors from the texture and create this kind of image, instead of doing all of that, we kind of maintain like an array of every single pixel you see here on the screen, except for text, actually, because text is drawn by Java. We'll get to that later. But basically for the base game, we maintain this buffer in memory, which accounts for the color of every pixel, much like a texture. And we write to it every frame. In fact, we write to it much more than once per frame, because anytime we want to draw a tile, anytime we want to draw like the main character or a tree or whatever it may be, we have to basically like get those pixels from that texture and copy them across into that buffer. And that's how this kind of image is created. Wow, in the time of me drawing that, it got dark. We also have this like nice lighting going on here where we have like some torches, and you can see it kind of fades out almost like Minecraft lighting used to work back in the day. I don't know if they still do that, but you know, we have that. We have, I think, an animated like little texture here. So all of that stuff we're gonna basically remake. We have a timer here. To be honest, I think like I didn't give this too much thought before I kind of committed to this. Oh, and you can see that player kind of getting brighter and darker as we move in and out. That's kind of cool. But when there's other mobs around, it tends to break for some reason. So we'll probably fix that as well. I was saying I didn't give this too much thought. So like, you know, one of the things I just realized, yeah, there we go. He stayed lit, which is bad, is that we also have to render text somehow. And text rendering is probably going to be the hardest part of this project unless we use like just a bitmap font, which basically means we have like a sprite sheet or a texture atlas of every single character we want to render, every single glyph kind of already rasterized into pixels in that texture, and then we can kind of draw that. So we might do something simple like that so that we don't have to involve like, you know, free type or, you know, sign distance field fonts or anything like that to kind of just make this easier. Yeah, any questions? That's the game. So that's what we're gonna start remaking. And the other beautiful thing about this series that I haven't mentioned yet is that I have no idea what I'm doing. I'm gonna be doing all of this completely live. This is not going to be planned at all. I'm going to sit down, hit record, and see what happens. So like, hopefully it's not going to be too much of a struggle, but I just think that this way you'll actually see kind of, you know, more realistically how I actually work through this. Okay, so the first thing I want to do is we're probably not going to spend too much time today actually looking at the original code from Genesis, because we need to actually like set up the project in the first place and get everything up and running. So that's what we'll focus on today. I thought about it, and I think the best way to start is probably to use Walnut. Walnut is this kind of application framework that I made a while back. There's a video, I'll have it linked up there if you want to kind of find out some more info about that. But basically it's kind of more or less like an application framework, but it uses Vulkan and I'm GUI. And so the idea is all this UI is kind of rendered, on the GPU, and it's kind of more seamless to integrate with like game engines, or if you have other real-time rendering that you would be using, Vulkan for. Now, strictly speaking, like you could say we don't really need this. We could honestly do this in a number of ways, but the reason why I'm going to pick Walnut for this is there's a few reasons. First of all, the presence of UI, the presence of IMGUI there in the first place is actually going to be really, really useful to us, because that kind of just gives us a really nice platform to throw up some UI for debugging or anything we really kind of want to use while we're developing the game. If we want to like display like some information, in the UI, if we want to make some sliders or controls so that we can adjust things, maybe load certain levels, dump some information on the screen, that's going to be really, really helpful to us. The other thing is, because this is kind of designed to be used with Vulkan, right? So you can seamlessly blend real-time Vulkan rendering. I think what we're going to do is initially we are still going to kind of write everything pixel by pixel into that array, just like the original Genesis. But I think maybe it would be cool at the very end of this to kind of, once the game's done, to kind of branch it off or to make a fork from it and basically make like a hardware accelerated version. So we would use Vulkan to actually make the game. We would actually like render it using Vulkan and shaders and all of that stuff on the GPU, rather than kind of software rasterizing it, into all these pixels. And then we can kind of compare that and also see how that transition would go. I think that would be kind of interesting as well. So let me know what you think of that. And so for the time being, the strategy is going to be like, since Walnut has IMGUI and Vulkan, we're going to use IMGUI to basically draw us an image. So we can do like IMGUI image, right? And that's going to just kind of draw an image inside a window. And this image is going to be a Walnut image that we create, and we'll write to that image basically every frame by setting our buffer of pixels like into it. So at the end of the day, it's going to be Vulkan that draws the game, but it'll be drawing it as if the game was just a texture that we update every frame. That's going to be like the initial strategy. This is actually exactly the same way that my ray tracing series works. If you've been around my channel, you probably know I have a ray tracing series where we're building like a ray tracer, and that's all kind of based off of Walnut as well. That's exactly kind of the same way that it works. We basically have, let me just go into source here. We have like our renderer, and that will write pixels into like this buffer called image data. So you can see that's just like a regular array. And then what will happen is we'll do image set data, and then we just set that buffer, and that's kind of it. And anytime like anything resizes, we have to delete that buffer, reallocate it, and then we also kind of recreate the image with like the new width and height as well. And that's all kind of present inside Walnut, so we can just use that API. And then the other thing with Walnut is that there is actually a Walnut app template, which I just updated just so that it points to like the latest Walnut submodule here. So we can actually just use that like as a starting point if we want to make an actual application. And you can see it's very simple. All we have to do is customize like the pre-make file and like change the name from Walnut app to like Genesis, and we'll kind of build it from there. Before we get into it, I want to thank Brilliant for sponsoring this video. Brilliant is honestly a really good resource for all of you who are learning programming and also want some help with math, because what it is an amazing website filled with many courses on various STEM topics. They have a computer science section with some great courses that can kind of help you think about programming in a better way, which I think would be useful to a lot of you who are kind of watching these videos to become better programmers or to learn programming in the first place. And personally, I love using Brilliant for their math courses. They have some really high quality math courses on things like linear algebra or calculus. And they make it super easy to learn and understand with the way that they kind of show things visually. They give you widgets you can play with so that you can actually see the math work. And you can get started for free. Just go to brilliant.org/thecherno, just have a browse yourself and see if you like their courses. And if you do, Brilliant have been nice enough to offer the first 200 of my subscribers 20% off an annual membership. Huge thank you to Brilliant, as always, for sponsoring this video. Okay, so to set this up, really simple. Just grab that URL, go to a directory on your computer. You can hit Control-L to access this little title bar, CMD, enter. You get a command prompt already inside that directory, assuming you're on Windows. Oh, by the way, I didn't mention this. At some point during this series, I want this game, this new C++ version of the game, to work on Mac and Linux. So if you're not on Windows, I want to initially use Windows here, but eventually we will be supporting Mac and Linux, because I think that'll be a really cool kind of part of the series as well, to show how to port that to other platforms as well. And then once you have a command prompt over here, just type in git clone -- recursive and then paste in that URL over here. Now you can give it a name as well, which I suggest you do. So I'll call it Genesis. We should probably give the repository a name actually. Should I call it like Genesis 2023 or Genesis CPP? Genesis 2? I'll just call it Genesis Remake. How about that? And hit enter. You'll also obviously need Git installed for this, which for those of you who don't know, you can just Google Git, go to like downloads and just download for Windows and install it. And then that kind of recursive clone, the reason we did that is because we have a bunch of submodules that we also want to check out, such as the third-party libraries like GLFW, GLM, and IMGUI, as well as, well, Walnut is kind of a submodule of this as well. So if you just clone the template, you're not even going to get Walnut. So make sure you have that recursive in there. And now we basically have our Genesis remake, and we have that entire kind of Walnut app template in here as well. So it says, if we read the getting started, which I wrote, but to be honest, it was like 9 months ago, so I don't really remember. So we can customize Premake 5 Lua and the one inside Walnut app as well to our liking. So we can change the name from Walnut app to something else and then run setup.bat, and then it's in there. Okay, cool. So let's start by, I guess, modifying these files. I'm just going to open them with Visual Studio Code. All right. So instead of Walnut app, let's call this Genesis Remake. I'll just call it Genesis. I don't think this needs to, but like the repository will be called Genesis Remake because I actually already have the Genesis repository. I probably should have mentioned that. If you just go to my GitHub page and go to like repositories, you'll see everything here, you know, that I've talked about, such as the Walnut app template, but I'll have that linked anyway. Walnut, and then you'll also see, don't look through most of this stuff, it's very old and terrible, but here's Genesis, right? So this is that base code. So what I was showing you guys inside Eclipse here, the actual Java code, that stuff is all available here. You can just clone it for yourselves and check it out. So that's like the starting point we're going to be using. Okay, so back in here, I'll just call it Genesis. Yeah, so for that reason, that's why I can't call it Genesis, because there's already a repository called Genesis, so I'm going to call it Genesis Remake. We'll include, so the start project will be Genesis, and we'll include Genesis, and that can remain the same. So what that means is that Walnut app, we have to rename to Genesis because we're including kind of this directory, which will kind of include the premake 5.lua file inside that directory, and we'll call that Genesis. So basically workspace is like your solution. So we're calling the whole kind of solution Genesis, but then there's also a project inside the solution called Genesis as well as Walnut. And so that will be Genesis, and this remains the same. Yeah, everything here I think basically remains the same. We don't really need to touch anything. So hopefully if we go back and into scripts, if we double click on setup.bat, that should just generate all of those project files, including our kind of Genesis project file inside the Genesis directory, as you can see. And so the idea is Walnut is kind of like the engine, almost like the base library that remains here, but then Genesis is our actual game, and you can see there's a VCX project here as well, and the solution file is in the root of the repository, the root directory of your project. Okay, cool. So inside Genesis, we have Walnut app, and I guess the first thing we can do is just build it, see if it runs. I'm just gonna hit this button up here, green button, go, and it will compile IMGUI and GLFW and Walnut and everything basically, and it will run it, and this is what we get, okay? So we have like a couple windows, you can even drag them out, which is pretty cool. We have this like, you know, resizable window, which even has a file exit that closes our game, and that's what it says here. Now obviously like this by itself does not really look like a game, and we're going to talk about this probably later in the series, but I just thought it would be easier to kind of start from this, if that makes sense, because this will kind of cut down all the boilerplate code and we can actually get to, you know, where we need to go faster. Because at this point you can see how quick that setup was. I can basically start making the game now. But realistically, later on, what we're going to probably want to do is get rid of this like IMGUI doc space, basically, so that we can actually render like directly to the window ourselves, and then have IMGUI as like a separate thing on top of that if we decide that we need it. And that way we can also cut it out of the release build that we distribute. Because the other goal with this series is I want to actually kind of ship this game. Like I'll release it to you guys like on itch.io or something, so you can download and play like the finished product on Windows, Mac, and Linux. That's the goal. And so for that, I obviously like don't need IMGUI at all. We just want it like during development. And even though we're doing all the kind of software rendering ourselves, we still need a way to kind of have Vulkan draw like a full screen quad or full screen triangle or whatever, and like get those pixels. We'll probably have to like write a shader for that. Maybe we could just blit it directly onto a swap chain image instead. I don't know, but we'll investigate that like at the end. For now, we're just gonna basically make the game be an image inside one of these windows, which we can just happily dock here. We'll get rid of the IMGUI demo, and then you can see we basically have the game like inside this window. That's gonna be my first strategy, because that's just gonna be the easiest thing to do. Speaking of which, let's rename Walnut app to be called Genesis app. And then let's see. So we don't want the menu bar at all, so we can just get rid of that. I don't know if we need it realistically. Maybe it would be good to spawn some debug windows. Whatever, we'll add it back if we need it. And then example layer, I'm going to just rename that to be, I guess, game layer, because this, from here, it's basically going to be, like, our whole game's going to stem from here. We're not going to touch this function anymore, apart from, I guess, the title. We'll change it to be called Genesis, but that's kind of done. Everything's going to come from here, and it's a walnut layer, which has a whole bunch of, it's a walnut layer which has a whole bunch of different functions that we can override, such as onAttach, detach, onUpdate, and UI render. So onUpdate is going to be important because that's where we're going to do all of our rendering basically. And onUI render is just going to render any debug windows we need, and also like our kind of main game viewport. Maybe I'll just call it game. So we'll have game here, and our goal is going to be to basically render an IMGUI image. So for today, as I mentioned, we're not going to probably look at this Java code too much. I think my plan is just going to be to basically just get like an image up on the screen. We're going to try and have this be like a bit more bite-sized, these episodes, so that we can, you know, not have huge 40-minute long episodes. I don't know, do you guys enjoy like those long videos, or would you rather have more frequent bite-sized videos? I think it might just be easier because if we focus on certain things, you know, certain specific things in certain videos, like that might be more helpful to people. So if they want to like know how to, I don't know, render some pixels from a texture onto a thing or whatever, that's just that episode, instead of like it being, you know, one part of an episode where we do like 50 different things, if that makes sense. So I don't know, we'll see. So what was it? On update, float TS. But do we need that? No, well, actually, I guess what I wanted was onAttach, because onAttach is kind of like our constructor. The difference between the constructor and onAttach, there's not much. There's a crucial difference, though. You can see that if I just had a constructor here that just, like, created stuff, like, for example, I wanted to create an image. The problem with that is that if you look at when this constructor gets called, it's going to get called on this line over here. Right, so when we do walnut application over here and we create, oh no, it's not, sorry, it's going to get created here. Maybe that's fine then. Yeah, it probably is fine because it calls onAttach anyway. The reason why I was a bit hesitant here is because you can see application init will actually like create the window, and it'll also kind of you know, create our Vulkan instance. And loading an image or creating an image is going to involve Vulkan. And so we have to be careful, because if we try and do that before this line, which wouldn't be the case in the constructor, but if we did, then that would mean that that wouldn't work, because what Vulkan doesn't exist yet. We haven't really created Vulkan, but here we are trying to create an image with Vulkan. So that's just something you need to be aware of, like the kind of order of initialization will matter. But again, here, if we actually look at the code, we know that walnut application, the constructor here will call init inside the application class, and it will kind of create all the Vulkan stuff, initialize all that stuff. And so when we do app push layer, game layer, you can see what that will do is, because you're doing std make shared with t, and t is game layer, you're basically, you know, you're creating a shared pointer from this game layer class, which is going to call the constructor, and therefore that's fine. So in this case, it doesn't actually matter. I guess I can just do it inside the constructor to make it a bit more easy maybe to understand, but again, it doesn't matter, because they're going to happen at the same time. Because you can actually see in push layer that as soon as we create this and then place it back, we call on attach immediately. So it's really not going to matter. Okay, so if we do image equals, now image, let's look at the image class. So walnut image is a class that comes with walnut, which is just supposed to be like a really nice kind of helper for us to basically create like images or textures in Vulkan. So you can see what it does is there's a couple constructors here. There's one that takes in a path, like a file path, and there's one that takes in width, height, an image format, and a pointer to some data. So this is the one we're interested in, because we'll be kind of bringing our own data. We don't want to load an image at this stage from disk. Eventually we will want to, because we want to obviously load all of the textures. By the way, I didn't really quite mention that, but there are, like, this does include you know, all of the assets that we have here, such as this. That's a terrible, look at this level design. I was just like, yeah, that's hilarious, just give me a level. There's a lot of them there, you know, made in like, what, 20 hours I think I made this game in, or something like that. But I think Ocean is the name. Yeah, see, so we're going to reuse that, obviously. And then sprites.png is also a sprite sheet that I made. So here's the player. Oh, I remember. I had the player as like very big first, but then I was like, that looks stupid, so I made him not that big. And this is also a bit stupid because I could have just programmatically changed the green to be pink, so maybe we'll do that actually. And then there was this lion. Oh, this is all coming back to me. There was like a lion that I made that I didn't use. Oh, this is kind of cool. And then you can see here are the tiles. So there's like some grass and like some flowers, some rocks, you know, the torch, the trees, the snow trees for the snow map, and the snow tiles for the snow map. And then this kind of, there's two of these because it's kind of an animation that it flips between these two, and that's ice over here. Some kind of very stupid looking rock here. So basically, yeah, this we will we'll use all of the original assets, which I think will be kind of cool. And then also, yeah, you can see that we have the pink here because this is kind of like transparent. Like these colors are going to be, when we copy the pixels of this kind of cell into our array, we will not copy the pixels that are of that color, thereby kind of creating blending in a way. Well, not really blending, we're just discarding those pixels. There's no actual blending. Like there's no blending would be if you have something that's partially transparent, you know, translucent, and you blend it with what's existing kind of already in that base buffer that you're writing to, which we do none of that because everything here is either opaque or completely transparent. But yeah, we'll be using that. And obviously the original levels, because why would we want to make better ones? So that's going to be funny. But so we will need to eventually, you know, load images from file, which is fine because Walnut supports that. But for now, let's go ahead and try and do std make shed. We'll do walnut image. I'm not going to like using namespace walnut here, I think. And we might actually end up bringing this out. We probably should end up bringing this out into its own file. But let's first make the image. So what's the width and height of this image? So we kind of want it to be the width and height of whatever window we render to. This is, again, very similar to the ray tracing series and the setup we did there. So I'm going to kind of speed through this. But this should be self-explanatory, I think. So when we make it, I mean, is there even any point in making it here? I don't know. I mean, we want to render it here, so we could probably just lazy kind of load it. We could say that if the image doesn't exist, which we haven't even made the image actually, so let's just grab std shed pointer walnut image. We could say if the image doesn't exist, we'll make it here, and then we have to make it with whatever the kind of width and height's going to be. So this is all kind of, this is already getting a little bit confusing, unfortunately, because we need the image to dynamically resize. So it's not as straightforward, but I guess let's kind of do this. I'm going to try and do this in a way that doesn't confuse too many people too quickly. So first, let's just make an image that's going to be 960 by 540. I mean, technically speaking, the original Genesis did actually have a fixed window size. You can't resize it. But I figure, I don't know, do we keep that or do we not? Drop a comment below as to like how closely I should match this original game. Should I make it resizable? I think I probably should, because it'd be nice to just make this full screen and play it full screen, right? Like, you know, we might as well like add some improvements to it, like along the way. But if it wasn't, I guess it would technically be easier because we could just hard code basically everything, but let's not do it that way for now at least. So 960 by 540 is an example, and then we'll do image format RGBA. We don't need RGBA 32F. Okay, so that's our image, and then what I want to do is so to draw it, we can just do image get descriptor set and then set like a size. So we can set a size to be let's do image get size or get width, image get height. And we can, I think that's going to return like a uint, so we can cast it to a float to avoid any warnings from the compiler. Add the little curly bracket at the end, which is, oh no, hang on, sorry, no curly bracket. I used the normal parenthesis for the constructor here. And that's kind of it. So let's maybe try running that. I wonder what will happen here. Yeah, okay, we'll just get a black screen. So if we grab this, looks like we've got some kind of invalid image layout. Oh, well, yeah, because we haven't written anything to this. So one of the things we should do is we've set no data here. So what I want to do is I'm going to create an array like we have inside here, kind of. So if we look at the screen class inside the Java, you can see that I create this kind of array here of integers called pixels. So we're basically going to do that. The only differences we're going to have here we're going to make it a uint32t pointer instead of just a normal int, which is what the Java one had. The reason being that I think Java doesn't have unsigned integers, or at least it didn't back then in like Java 1.6 or whatever this was written in. Yeah, I mean, I prefer to work with unsigned integers when we're dealing with like pixels, but again, fundamentally it doesn't matter. The data's kind of the same at the end of the day, but this just is better for me. We'll call it image data, and we'll make it a pointer, and we'll set it to null pointer, because we need to, this also needs to kind of be the size of our image. So for example, in this case, when we create it, we know it's 960 by 540, so we can kind of just create that and we're done. And now this holds because it has that many integers in it. Each integer is going to be one color for 1 pixel, right? So if we go through, you know, that whole array, for example, 960 by 540 like this, we can make it pink by basically just doing image data I equals and then the color. Now it's going to basically be RGBA as far as I'm aware. So the most significant bits here are going to be the alpha channel, and then we're going to have blue, green, and red. That's kind of the way I believe it's going to work. So it's kind of not, it's not like RGBA, it's ABGR. Because we kind of, that's it, because the bytes are flipped. It's almost like a little endian, big endian kind of thing. So the least significant bits are going to be the red channel, I believe. So what that means, and again, it won't really matter for this as long as you don't get your alpha mixed up, because you won't know which one's red and blue because they're the same. But if we try and now basically take the image and set its data, so set data to be image data, right? Alternatively, we could, of course, bring this down, and then instead of doing that, just put image data into here, right? We're going to have to set data every frame anyway, but we'll do this for now. You can see we get a nice pink window here. Now, it will always remain 960 by 540. And it looks like it still are some validation errors to do with a nice choppy. This might be some walnut stuff, which I might do outside of this series. But basically, we kind of have our game view, as you can see, and it's this. Now, the problem with this, though, is that, again, it's not the right size. We want it to resize. So what that means is that we kind of need to maintain, like, the size of this. Now, you can ask IMGUI what the size of the window is. If you do get content region available, no, I believe they deprecated some stuff. I think it was min and max, like width and yeah. So that should be fine. Get content region available, and then X is going to basically be the width. So if we just do like window width equals that, which will cast to a uint32t because I think this returns a float, and window height, we can basically just check to see whether or not they match the size of the image. So if window width doesn't equal image get width, or so if either of them are different, doesn't equal, if window height doesn't equal image get height, then we know that it needs to be updated. So we can basically say, okay, well, you know what, image, why don't we recreate you with whatever the width and height actually is, and then we'll have to also recreate image data. So we'll delete it first so that we like you know, free that memory, and then we'll create it like we did here, but this is going to be window width, window height. Maybe I shouldn't have called it window because, well, it is this window, but it's not the whole window. It's just this IMGUI window. What's your problem? Using operand on a 4-byte value can result. Ugh, that's the stupidest thing ever. It's saying that this can result in a value greater than that 32-bit integer. So therefore, you should like cast it or whatever. So what? It wants me to do this. Isn't that just like? Isn't that just? Imagine that. No, we're gonna say no to that. Okay, and then we'll have to, well, we should be setting the data every frame, really. So let's maybe say that before we do this, or actually that it will be technically done in update. We can kind of, you know, maybe we should even have an else. So we skip that frame, or is that going to be weird if we skip that frame? The problem is that we react to the resize here, but then we probably will want to set the data inside our update. Not that it really matters. Like if you were to look at application, I guess, to just see where this stuff's called, you can see this is called here as like the first thing really in the entire frame, because here's the while loop. We call this here, but then on UI render is probably called in like the dock space over here, right? And so what does that mean? That means, so it's called a bit later. This is it being called up here, first thing in the frame. This is being called down here, inside here, right? So the problem here that we need to think about is if we go ahead and say, let's basically delete the image because we're, recreating that shared pointer, so it's going to delete the old one as long as there are no other references to it. Then we kind of have to think about, well, do we immediately display that image if the game hasn't rendered to it yet? Or do we then get the game to render to it here, basically, or the game to kind of, set its pixels into this Vulkan texture here, and then we draw it? Which I guess we could do. Like we could say, okay, well, if the window is suddenly a different size, then recreate this, do the image data, and since you've just done that, then maybe you could do image set data, image data. I guess that would be fine. No, actually it wouldn't be, because we just created a blank array here of garbage, probably. Especially if it's not initialized. And then we're setting that here. So that's going to be... We need the game to actually populate it again. This is an example of the game populating it. So I don't know. It's getting tricky. Episode 1. And it's already a struggle. Yeah, I don't know. Because my ideal way to do this would probably be like that. But the problem is that if we then see that it's different here, then we react to it immediately, But I probably don't want to do that. In which case we could just... But we can't not render that whole image. I say we almost want to render the old one. So how about we just do... Oh, but we don't know the width and height. Yeah, that's why doing the resize here reactively is kind of dangerous. The other option, to be fair, is we could just do it here. So we draw the image at the old width and height, and then we like... No, that's not going to work. Oh, no, maybe it will. Because I think the image destructor will call release, which, yeah, you can see I wrote a little submit resource free. So it won't actually delete the texture from GPU memory until after it's drawn it. So that actually will work. So I think that'll be okay. So hopefully you guys can kind of see my thought process as I go through all of this. I'm really trying to talk out loud a lot and in as much detail as possible. So let me know if that's good. Okay, so let's just run this and see what happens. I'm a bit scared. Okay, that worked. I think that's working. So you can see we can resize it, we can drag this out, like everything seems to be working, and it's always going to be the size of the window. It's hard to tell now if it's like stretching or whatever, but because it's just all one color, but I'm sure it's probably working. The last thing we can do is try and randomize the data a bit, because at this point we can't see whether or not it's changing every frame. So what we could do is just use a random, random uint or something inside the walnut random class, which we have to include. And if we do that, it should just scramble it to like a random color, basically every frame, as you can see. Probably want to run it in release mode if we're doing that, because that's a decent amount of pixels that we're randomizing here. It'll be fine in release mode, but in debug, like it can be slow, so you just want to watch out for that. But it's probably not going to be this slow when we eventually deal with it. Okay, cool. So that's kind of working. That looks good to me. What else can we tackle here? Oh yeah, okay. So if you look at our window here, you can see there's like this black border, right? And that's just because IMGUI has some window padding by default. So what we can do is before we actually begin the window, we can do IMGUI push style var, IMGUI style var window padding, and then IMVec2, 0, 0. And so that's just gonna basically set the padding to 0, and then at the end we have to pop it. So pop style var. And that will just get rid of that padding so that it's nice, and you can see there's no border now. It's nice that it's like exactly at the end. I feel like there was something else I wanted to do. Or is that a good first episode? I don't know. Oh yeah, scaling. I wanted to kind of talk about scaling, because remember, this game has a scale. So basically what happens here is every pixel that we have here is actually scaled up, like, I think by 3. So every pixel is actually a 3 by 3 pixel. And the reason why is because inside game, you can see we have like this pixels array, but the width and height is actually 300 by, you know, whatever that is, 180, 300 by 180, but then the scale is 3. Because what we're doing is we're actually like scaling it up by 3. If it wasn't scaled up, if it wasn't like, you know, upsized, the actual image, and we had like say 900, because that's what it would be, you can see everything's gonna look like super small, like that. If we hit play, you can almost see like the whole island. And we kind of get that, you know, retro look by having low resolution graphics, but scaling them up. And that's obviously very important to maintain. So the way we would do that, and to be honest, we're probably gonna have to go into the sampler and actually change some things. But the way we would do that is we would have a scale, UN32T image scale. We could set that to like 3. And then if we come over here, when we make the image, this doesn't really matter. We honestly don't even kind of need to do that. It'd probably be worth not doing that. But when we do this, we want to basically do window width divided by the image scale and window height divided by the image scale, right? And same with this. So it's going to be window width divided by image scale and window height divided by image scale. So the critical thing here is that each like dimension is being divided by the image scale. So it's not like the overall pixels are being, you know, divided by 3. It's the width and the height being divided by 3, which is kind of why we put it in both of these, not just at the end. So that's done. Now that, so basically the difference here though is window width and height. They're not going to be scaled. They're going to be the actual like real width and height. So we need to kind of make sure that if we go down that route, we also divide these by 3 so that they match this. Otherwise this comparison is always going to be wrong. And probably to reflect that, I might rename this to be scaled window width and scaled window height, because otherwise it might be a bit confusing as to why on earth we have divided by 3 here. And then, but the difference is that when we draw the image, which actually I already changed, well, no, where do we draw the image? Here. When we draw the image, we do times scale, right? So we're kind of stretching the image, making it larger than it actually is, but the image data itself is tiny, kind of like this. Okay, we need to also make sure that, yeah, this is already the scaled one. So the scaled one, we obviously don't divide by 3, my mistake. Because otherwise we're applying that scale twice, which is why we saw such a tiny image. And there you go, right? So what happens here is we have a very blurry image, but you can see it's been scaled up. And the reason why it's blurry is just because we're using a linear filtering kind of function, I guess. It's basically like when it scales up and it needs to create obviously more pixels out of like the ones it has, it looks at the neighboring pixels and it kind of blends between them in a linear way, linear interpolation. That's why we get that kind of blurry look. If we want it to remain sharp, kind of like Minecraft textures, then we need to use nearest filtering, or point filtering it's sometimes called as well. So to do that, to get really like deep here, if we actually go to application, the reason why it's using linear filtering is because we've told it to use linear filtering. So if we go into actually, would that be, does the image ship with its own sampler? I don't remember where this is. Yeah, create sampler. So you can see that in the image, in the walnut image we created, we set its sampler to be linear for the magnification and the minification. So if we changed this to be nearest, and really magnification is kind of what we're after here, because we're making it bigger, we're magnifying it, then, okay, it's still blurry. Yeah, because I wouldn't have expected it to be here. I don't even know what this sampler is used for. But we do add this texture when we create the descriptor set. So I just have a feeling that it uses its own sampler. Like IMGUI uses their own sampler when they draw that. Because that, unless I was stupid there, but I'm pretty sure, yeah, that's definitely linearly interpolated. Maybe next episode would be a good opportunity to show how I would approach debugging like a little rendering graphics issue like this. But anyway, let me know what you thought of this kind of first episode of this new series. Hopefully you enjoyed the format and we can kind of have some fun, just chill out and have a good time. Thank you guys for watching. Don't forget to check out Brilliant using my link in the description below, and I will see you next time. Goodbye.